So we were talking about the fundamental counting principle a couple of minutes ago, and I wanted to move on to something a little bit different because what if we have something, we have repetition, or we have something without repetition? And it'll all make sense in just a second, so hopefully you're hanging in there with me. Let's start with this example that the standard configuration of a DC license plate, the license plate on the back of your car, is 2 letters followed by 4 numbers. So how many how many distinct license plates can be made? Can be created if repetition is allowed. Let's talk about what that means, repetition, in just a second. Is allowed. So here's my question to you. We know that this is going to be a letter here, isn't it? So we're going to put a letter here. It says 2 letters followed by 4 digits, by 4 numbers. So, and you know what? Let me change numbers to digits so we can be more specific. With 4 digits here, right? Well, how many letters could be placed here in the first spot? How many letters are there to choose from? There's 26. So imagine that you chose one of those letters. You chose, right. If you chose the letter that you just thought of, how many, in repetition is not, is allowed, I guess we're at is allowed, then could you choose your letter again? And I think the answer is yes, isn't it? So how many letters could you choose from? Well, you could choose from 26, right? And it says where is followed by 4 digits. Well, how many single digits are there? How many digits are there? There's 0 through 9, right? How many is that? That's 10, isn't it? And how many choices would you have for the next number? 10 and 10 and 10, right? And then we'd use the fundamental counting principle and we'd multiply and we'd get 10 times 10 times 10 times 10 is, take out your calculator. I know what the answer is, but is 10. So 10 is 10,000, isn't it? So we'd have 10,000 choices right here, just without regard to that. And then we'd have 26 squared, which is 676, isn't it? 676. And 676 times 10,000, and if you're wondering, yeah, I'm using my calculator because I don't want to screw this up, is 676. Right? So we'd have almost 7 million different distinct license plates possible, wouldn't we? Okay, but what if repetition is not allowed? So what if we change this and say is not allowed? That is to say, if you chose this, so let's say that you chose, let's say, how many choices did you have to start with, right, for a letter? 26, right? So you chose A. So if you chose A here, if repetition is not allowed, you can't have A here also, right? We're excluding, we're saying you can only use it once. So then the numbers change a little bit, don't they? Your first choice of letters would be 26 letters, right? But you chose that letter that you chose. So you can't use it again. So how many letters do you have left? Exactly. So there are 25. Same thing here. So you go to choose your first number. How many choices are there? It's 0 through 9, so there are 10 choices, right? But you chose one of them. Doesn't matter which one you chose. Write down all the possibilities. Choose one of them, and how many are left? 9, right? There are 9 choices left, aren't there? So now you've chosen 2 of the 10 possible, right? And that leaves 8, doesn't it? And then here leaves 7. This becomes, is it going to be a bigger or smaller number? And I think the outcome is obvious, right? And then we'd have to do that. We'd do 26 times 25 times 10 times 9 times 8 times 7. Oh my goodness, it's a lot different. I mean, it's amazing how much it changed it. If you're doing the math with me, it's 3,276,000 choices. And if you're sitting there going, yeah, well, that's still a lot. I get it, but look how many choices we had before, right? Before we had over 6 million, and now we're down to 3 million. We were closer to 7 million on the first answer, and now we're down to less than 3.5 million, so that makes a big difference. All right? Okay. I'm going to leave you there, I think. Looking for your comments. Hopefully it worked out terrific for you.